Okay, I am sorry that video ended kind of abruptly. There's been all sorts of interesting things happen when I was trying to video yesterday afternoon. So I have turned my iPad on Do Not Disturb. There is a note on the outside of my door that says I am recording, and so I am hoping that there will be no more setbacks with this. The other thing that I want you to know is that I have a funeral that I have to go to tomorrow, and so your test is being postponed until Thursday. So you actually get an extra 2 days to study. I was going to try to go ahead and give it anyway and ask someone to cover the test, but I decided that you guys would probably like the 2 extra days, and it's daylight savings time week, and that always makes things interesting. So that is what we're going to do. We are going to have the test now on Thursday, and I will send that out in an email. I'll post it. You'll get lots of information about that. Okay. When we last left this problem in the first video, we had decided that this had 5 factors. It also has 5 zeros, and we had found those zeros. We have x equals 0, we have x equals -4, and we have x equals 3. We also have determined the shape of the graph, the end behavior of the graph, because we have that negative in front. So it's going to look similar to a negative slope of a line. So I am going to draw an x and y axis. So here's my x and my y axis. Okay, and I'm going to put my marks on my x-axis. So I have an x at 0, and the multiplicity of that is just 1. And so because my multiplicity is 1 at x equals 0, that means the graph's going to go through the x-axis. At x equals -4, I have a multiplicity of 2. That shows up 2 different times because x plus 4 is squared. So my multiplicity of x equals -4 is 2. So that means that my graph is going to bump -4 and then change directions. Now, we don't know if it's coming from the bottom or the top, but that's what's going to happen at -4. At x minus 3 equals 0, that also occurs 2 times. So at x equals 3, my multiplicity is 2, and so I am also going to hit the x-axis and change direction. Now, over here on the right, we have the shape of our end behavior. So that tells us that we are going to start up here. And then because I have a multiplicity of 2 at -4, I'm going to go down and I'm going to bump it, and I'm going to come back up. Now, we don't know how high it goes or anything. We don't know where our relative maximum and minimums are, and that's okay. So then we're going to go back. We go through x equals 0 because we only have a multiplicity of 1 there. Again, we don't know when it turns. We hit x equals 3, we touch it, and we change direction. And so this, and it should be a very smooth graph. This is what the sketch of our graph looks like. Okay, so let's move on to the next problem. So I am on number 4 now. And number 4 is giving us a whole lot of information. We have a whole lot of information, and we've got to determine from that information what our polynomial function is. Now, I'm going to graph it. It's not asking us to graph it, but when I graph it, it does give me a better idea of what I'm looking for. So I'm going to graph it even though it doesn't say that I am required to graph it. Okay, so it says give a polynomial f of x, so that's where we're going with this, f of x, whose graph rises on the left and rises on the right. Okay, so rises on the left and rises on the right. We don't know what happens in the middle, but we know it rises on the left and rises on the right. So that also means that our leading coefficient is going to be positive. That's what this tells us. And that our exponent is going to be even. Okay, then it says it passes through the x-axis at -1, 0, and 2, 0. So at negative 1, 0, our graph passes through. At 2, 0, my graph also passes through. So at negative 1 and 2 on the x-axis, I'm passing through. Then it bounces off the x-axis at 4, 0. So here's 4, and it bounces at 4. Now, our end behavior is that it's both going up. So if I look at this, whoops, sorry about that. Okay, so if I look here, I'm going to be going in that direction. And here, I'm going to be going up. Okay, I pass through at x equals negative 1, and I pass through at x equals 2. But at x equals 4, I bump. Now again, we're not going to know exactly what our maximum minimums are. And we also don't know what our y-intercept is. But we do know what's happening at the x-axis. Okay, so if this right here, let me change colors just so we can keep it separate. If this right here is x equals negative 1, our factor associated with x equals negative 1 is x plus 1. And that is only going to occur one time because it goes through. Okay? So my multiplicity for that is 1. Okay? Here, I've got x equals 2. If x equals 2 is my solution, x minus 2 is my factor. Because it goes through the x-axis, we know that's only going to occur once. So I have x minus 2. Okay? Now my last solution is x equals 4. Okay? If x equals 4 is my solution, x minus 4 is my factor. Now we know that that occurs twice because it tells me that my graph bounces off the x-axis. So that means it touches it and it changes direction. So that has a multiplicity of 2. And if we were to multiply this out, and I'm not asking you to multiply this out because you would end up with 2 trinomials times each other, then you would have your polynomial. But all I'm asking for is this set right here multiplied together, and that is your answer. Okay? Now let's look at number 5. Number 5 is asking us to divide. We're going to do lots of synthetic division, but this one lends itself very nicely to synthetic division. And so we will definitely do synthetic division when we're using the rational root theorem and a couple of other things. But here, I'm also going to use synthetic division. The next two, I'll use long division. So what I'm going to do is I am going to put 4 in the box. And the reason that I'm putting 4 there is because I am looking for the solution associated with the x minus 4 factor. So I'm going to put 4 in the box. Then I am going to make sure that I write down all my coefficients. So 1 is the coefficient for x to the 4th. Negative 2 is the coefficient for x to the 3rd. Negative 13 is the coefficient for x squared. 28 is the coefficient for x, and negative 32 is my constant. Okay, so I bring my 1 down. 4 times 1 is 4. Negative 2 and 4 is 2. 4 times 2 is 8. Negative 13 and 8 is negative 5. 4 times negative 5 is negative 20. And 4 times 8 is positive 32. Okay, so I have a remainder of 0, and if you remember, when I get a remainder of 0, that means that x minus 4 is a factor of my larger polynomial, and that 4 is a solution to this polynomial. Now, we're only being asked to divide, so what you need to do now is you need to write the answer. And so my answer here is, and if you remember, this is my remainder, this is my constant, my x value, my x squared value, my x to the 3rd value. So my final answer to this is going to be x to the 3rd plus 2x minus 5x plus 8. Okay? So that is the answer to number 5I. Okay, so for this one, we have 5x to the third minus 7x squared minus 22x minus 9 divided by 2x minus 6. Now, the directions to this say divide the given polynomials using any appropriate method. Because of how this is set up, we are going to use long division on this one. Synthetic division is used to help us find zeros. So if I was finding the zeros of this polynomial, and I was told that 2x minus 6 is a factor of this polynomial, what I would do is then I would set 2x minus 6 equal to 0, and I would essentially get x equals 3. So 2x minus 6 is x equals 3. Then I would use the x equals 3 in my synthetic division, and then I would use each of my coefficients to set up my synthetic division problem. And that is a perfectly acceptable way to do this if you are finding zeros. The directions here say divide, so that makes it a little bit more cumbersome because of this 2x minus 6 that we are dividing by. So I am going to set this up in a long division problem. So I have 2x minus 6, and then I have 5x to the third minus 7x squared minus 22x minus 9. Okay, so the trickiest part is that very first one. So I have 2x, and I need to know what do I multiply 2x by. So 2x times what is going to give me 5x to the third. Okay, so we know there's going to be an x squared in it because x times x squared is x to the third. But I also need to get the 5. And what I multiply by is 5 over 2. 2 times 5 is 10, and 10 divided by 2 is 5. So my coefficient, when I start doing my division, it's going to be 5 over 2 x squared. That is how I start this problem. And I know that figuring out that 5 over 2 is the tricky part of that. So now we do 5 over 2 times negative 6. So that's negative 6 over 1 times 5 over 2. Okay, we get negative 30 over 2, which is negative 15. And that's going to be negative 15x squared. Okay, then we've already talked about here how 2x times 5 over 2x squared is 5x to the third. So I have 5x to the third here. Now, if you remember, when we're doing long division, we change the signs. We're subtracting. And that's what we want. We want that to be eliminated. Negative 7x squared and 15x squared gives me 8x squared. At this point, students typically do okay. So I have 2x times what gives me 8x squared, and that is going to be positive 4x. Positive 4x times negative 6 is going to be negative 24x. Positive 4x times 2x is going to be 8x squared. Again, we are subtracting, so we change the signs. Our 8x squared and negative 8x squared simplify. Negative 22x plus 24x leaves me with 2x. I bring my minus 9 down. Okay, I'm just erasing so that we can see everything. Okay, 2x times 1 gives me 2x. So 1 times negative 6 is negative 6. 1 times 2x is 2x, and I'm subtracting. Okay, so I am left with negative 3. So I have a remainder of negative 3. And I know many of you are going to want to write that as remainder negative 3, but that's not what we're going to do. We're going to have our final answer here is 5 over 2x squared plus 4x plus 1. Then I've got negative 3, and I am going to write that over what I am dividing by. So this is actually your final answer right here. Okay? Okay. Let's move on to the next one. The next one is x to the third plus 2x squared plus 8 divided by x squared plus 5. For this one, we are also using long division because of our x squared there. So x squared plus 5 is going to go on the outside. X to the third plus 2x squared plus 8 is going to go inside. So I have x to the third plus 2x squared plus 0x. And if you notice, we go from x squared to our constant right here. So I have to account for that 0x. I've got to account for that linear term. That's why I've got my 0x there. I have to do that here with the number that, or the polynomial that I'm dividing by. So I have x squared plus 0x plus 5. Okay? Now, for this one, I ask myself, x squared times what gives me x to the third? And it's actually x. So x squared times x will give me x to the third. So I want you to see, I wrote that over the linear term. And it's kind of a place value thing. So you want to write it directly over the same type of variable with the same exponent. So I have x over my 0x. So that's why it's written right there. So now I'm going to multiply. X times 5 is going to be 5x. X times 0x is 0. Anything times 0 is going to be 0. Then I have x times x squared, and that is x to the third. Now I am subtracting everything. Okay, so I have to change my signs. X to the third and negative x to the third cancel. I'm left with 2x squared minus 5x. And I'm going to bring down my 8. Okay, so then I say x squared times what gives me 2x squared. And the answer to that is 2. So I'm going to multiply everything times 2. So 2 times 5 is 10. 2 times 0x is 0. 2 times x squared is 2x squared. And again, I have to subtract, so I'm subtracting all this. In long division, we have to subtract. So now I am left with negative 5x plus 8. Negative 5x. Whoops, I made a mistake. I was looking at all the zeros. So I have negative 5x, and then I have plus 8 minus 10. So that is going to leave me with negative 2. So I have negative 5x minus 2, and that is my remainder. And I know that you probably want to stop there, but we can't. We've got to put that remainder over what we are dividing by. So my answer is x plus 2 plus negative 5x minus 2 over x squared plus 5. And this is my final answer right here. Okay, let's move to the rational root theorem. Using the rational root theorem, find all rational zeros of the given polynomial. Now for practice, I just want us to find all the zeros. Now, this particular one, it can be factored. I would tell you that if a problem on your test can be factored, I would factor it. I wouldn't always use the rational root theorem. The directions on your test are going to be find all the solutions. You are going to have to use synthetic division in order to do that. But I do want us to talk a little bit about the rational root theorem. So the rational root theorem talks about using this number, which is our constant, and using our leading coefficient. So we are going to look at the factors of 3. And the factors of 3 are plus or minus 1 and plus or minus 3. Okay? Those are the only factors. Then that's going to be over the factors of this 1 right here. So plus or minus 1. Now, a lot of them get much more complex than that. But so this would be, so we could take positive 1 over positive 1. We could take positive 1 over negative 1. We could take positive 3 over negative 1. We could take negative 3 over positive 1. These are all the different examples that you can get. Now, the reason that we use this is because it helps us to know where to start with our synthetic division. So as long as you start with one of these factors, you're going to be fine. And like I said, this particular problem can be factored, but we're gonna use synthetic division to solve this. I'm going to start with 3. I'm going to see if 3 works. So I'm going to put 3 in my box. So I'm going to have 1 x to the third minus 3, because that's my x squared, minus 1, and plus 3. Now, I could have put 1 here, I could have put negative 1, and I could have put negative 3. Any of those numbers would have been completely fine to put in that box to try out. So I bring down my 1. So 3 times 1 is 3. Negative 3 plus 3 is 0. 3 times 0 is 0. Then I combine those and get negative 1. 3 times negative 1 is negative 3. Okay, so my remainder is 0. This is my constant. This is my x. This is my x squared. So my answer to this is x squared minus 1. Now remember, this is a solution. Okay, 3 is a solution. And if 3 is the solution, x minus 3 is the factor. Sometimes when students do this is they forget that original solution that they used in the synthetic division is still part of your answer. Now here, x squared minus 1 factors to x plus 1 times x minus 1. I've still got my x minus 3. So my solutions to this are negative 1, positive 1, and positive 3. Now, if you decided to FOIL on this, that would have been completely fine. Okay? I'm sorry, if you had decided to factor on this, you would have gotten the same answer. I shouldn't have said FOIL. We are factoring. And so it's fine. So you don't have to use synthetic division if you can factor. The directions said using the rational root theorem. But I do want you to kind of be aware that factoring would have been fine in this situation. Now, our next one, we have 2x to the third minus x squared plus 8x minus 4. This one can also be factored, and I think this is much easier to use factoring. An x squared comes out of both of these. So I have x squared times 2x minus 1. And then a 4 comes out of both of these. And actually, it's going to be a positive 4. Sorry about that. It is positive 4. And so then I'm going to have 2x minus 1. So for this, I end up with x squared plus 4 and 2x minus 1. Okay, 2x minus 1, that is going to be my factor that gives us a rational answer. So my only rational and my only real answer to this is x equals 1/2. When I look at x squared plus 4, I have to set that equal to 0. And when I start solving for x squared, I get x squared equals -4. I have to take the square root of both sides, and when I take the square root, I've got to add my plus or minus. So I end up with x equals plus or minus the square root of -4. That negative inside the square root simplifies to an I outside the square root. And then the square root of 4 is 2. So my answer here is plus or minus 2i. So I have 3 solutions to this. X equals 1/2 is my only real or and rational solution. My other 2 solutions are complex. I have plus and minus 2i. Okay, and I know that we were asked to find all rational zeros. The only rational zero we have is this 1/2. Now I'm going to erase this and show you how you would have gotten your 1/2 if you were only using synthetic division. When you can factor, it's a good idea to go ahead and factor. But if you can't factor, that's when you would use your rational root. So I'm going to erase all this. Now, based on this theorem, we look at the 4, or we look at the -4, and we look at the +2. So we are looking at factors, basically of 4. So we can have plus or minus 1, plus or minus 2, and plus or minus 4. And then I'm looking at the factors of 2. Okay, this is the rational root theorem. So these are the things that I would try to use for synthetic division. Now it does get complicated because you've got 1/1, 1/2, and 2. Then you've got your -1/2, your -1, your -2, your -4. So this gives you different ones to try. If it's not here, if it's not in that box there, there's no reason to even try it. So we know that our rational zero is 1/2. And it takes a little bit of time to find that. So I'm going to go ahead and write down my coefficients. Okay, 1/2 times 2 is 1. Okay, -1 plus 1 is 0. 1/2 times 0 is 0. 8 plus 0 is 8. And 1/2 of 8 is -4. And so I'm left with 0. So I end up with 2x squared plus 8. If I set that equal to 0, I can factor out a 2, and I'm still left with x squared plus 4 equals 0. Now don't forget, this 1/2, we've already determined that this 1/2 is a solution. The solutions here are not real. So if we look at the question, it says find all rational zeros. So 1/2 is the only rational zero, because x squared plus 4, that's going to give me zeros that are not real, and they definitely aren't rational. What you are more likely to see on the test is an example that says find all zeros, real and complex. So I want you to be aware of those. So again, the answer to this particular problem is x equals plus or minus 2i. Those are your complex solutions. And then you have 1/2, which is your rational solution. Okay? Okay, now we have operations with complex numbers. Operations with complex numbers. So here I've got the square root of -12 times the square root of -3. When we are dealing with real numbers, you are able to just multiply those two together and keep them inside the square root. But we're not dealing with real. So before we can multiply those, I've got to pull my I out. So I am going to have I on the square root of 12, and I is the square root of -1. And then I'm going to have I on the square root of 3. I times I is I squared. Square root of 12 times the square root of 3 is the square root of 36. I squared is negative 1, so you do want to keep that in mind, that I is the square root of negative 1, and I squared is negative 1. That's important to have. The square root of 36 is 6, so the answer to this question is negative 6. Okay? On our next one, we have 4 plus 2i minus 6 minus 7i. So first thing I have to do is distribute this negative. So I have 4 plus 2i minus 6 plus 7i. Don't forget to distribute that negative to both things inside that parentheses. Then I have 4 and negative 6. That gives me negative 2. 2i plus 7i gives me 9i. And so this is the answer to 4 plus 2i minus 6 minus 7i. The mistake that students typically make with this right here is they want to FOIL that. And they don't FOIL that. That's subtraction. FOIL looks like our part 3 when the two binomials are right beside each other. So we're going to FOIL this. I have 8 times 5 is 40. 8 times 5i is 40i. Negative 3i times 5 is minus 15i. Okay, negative 3i times positive 5i is negative 15i squared. Now what happens is a lot of times students will combine these like terms and then stop. But don't forget, I squared is negative 1. I squared is negative 1. So that turns that negative 15i squared into positive 15. And we can go one step further. And so we end up with 55 plus 25i. And that is my answer to multiplying those two binomials together. Okay? Our next one is we are rationalizing a denominator. So the rule is you cannot have an I in the denominator of a rational expression. So we have to get rid of that. So the way that we get rid of that is we multiply by the conjugate of this denominator. And when I multiply by the conjugate, I use difference of perfect squares and my middle terms cancel out. That's why we multiply by the conjugate. So 1 plus 2i and 1 minus 2i are conjugates. And when I multiply those together, my middle terms will cancel out. Because I multiply the bottom times 1 minus 2i, I also have to multiply the top times 1 minus 2i. So now I have negative 3i, and I'm going to multiply, I'm going to distribute 1 minus 2i. Then in the bottom, I have 1, or the denominator, I have 1 plus 2i times 1 minus 2i. Okay, I'm going to distribute my negative 3i. So I'm going to have negative 3i times 1, and that's negative 3i. Negative 3i times negative 2i is going to be plus 6i squared. Okay. In the denominator, I've got 1 times 1. I'm foiling the denominator. 1 times negative 2, I get negative 2i. 2i times 1 is plus 2i. 2i times negative 2i is minus 4i squared. And just as we predicted, negative 2i and positive 2i cancel out. That's what you want to happen. Now I've got negative 3i plus 6 times negative 1, because I squared is negative 1. Okay, then in the denominator, I have 1 minus 4 times I squared, which is negative 1. Okay, so now I'm going up here. So I have negative 3i minus 6 over 1 plus 4. Now, to keep it written in standard form of a complex number, I need to move that -6 first. So I'm going to have -6 minus 3i, okay, because that's standard form of a complex number. -6 minus 3i over 5 is a perfectly acceptable answer. A lot of students will split that and write it like this. And I want you to know that either way is fine. I'm comfortable with either. Okay? Now, the next problem, number 8, says, find all zeros, real and or complex, for the polynomial. So we're going to look at all the different, we're going to find all of them. Some of them may not be real, but we're still going to find them. And remember, if it's not real, that means it doesn't cross the x-axis. So if we have imaginary or complex numbers, that means our graph doesn't cross the x-axis. So the first thing I'm going to do is I'm going to factor out an x. I've got an x in every single one of these. So then I have x squared plus 2x plus 5. And so we would look at that, and then we would try to factor x squared plus 2x plus 5. That would be our next step. But when I start to factor that, I can't factor it. So I have to use the quadratic formula, or I have to use completing the square. Either one of them is completely fine. I have found that most students end up using the quadratic formula, and that's fine. Now, if x is a factor, our solution is 0. So we already know that x equals 0 is one of our solutions. So this is going to cross the x-axis at 0 because I factored out an x, and when I set that equal to 0, I get x equals 0. So don't forget about that. We start focusing on this trinomial and the solutions to this trinomial, and we get caught up and we forget that x equals 0 was the first one that we found. So I'm going to do the quadratic. That's negative b plus or minus the square root of b squared minus 4ac, and all of this is over 2a. Now our a is 1, that's the coefficient of x squared. Our b is 2, that's the coefficient of x, and our c is 5, and that's our constant. So I have negative 2 plus or minus 2 squared minus 4 times 1 times 5. And that is all over 2 times 1. Okay, so then we're going to simplify what's in the square root. 2 squared is 4, and that's going to be minus 4 times 1 times 5, which is 20. And that's all over 2. 4, I'm going to erase some of this. Okay. So I have negative 2 plus or minus the square root of negative 16. The square root of negative 16 is I, because we have the negative, and it's 4 because the square root of 16 is 4. So I have negative 2 plus or minus 4i over 2. Now, do you see how a 2 will go into negative 2? It will go into 4, and it will go into 2. That means you have to simplify this again. 2 goes into negative 2, negative 1 times. 2 goes into 4 twice. And then 2 goes into 2 once. So my answer to this is negative plus or minus 2i. And that's negative 1 plus 2i and negative 1 minus 2i. And so I've got 3 answers. I have x equals 0, and I have negative 1 plus 2i and negative 1 minus 2i. Don't forget that 0. 0 is our real. Negative 1 plus or minus 2i, that's our complex. Okay? Now we have 2 fill-in-the-blank questions. So the first one says, fill in the blank. A number k is a 0 of f of x if and only if x minus k is a factor. Okay? So, if K is a solution, then X minus K must be the factor. Okay? And we've talked a lot about that. Now, I don't think that you would, I don't think that you would think about this, but if we plugged K in, if we did f of K and got 0, that also means that K is a solution. So we did a little bit about the relationship between finding the function of that number and getting 0 and what that meant for that solution and that factor. I don't think anyone is going to think about that, but I do want just to mention that this is also true, that if f of K equals 0, then K is a solution. Really what I was looking for is the X minus K as a factor. Now, number 10 says, fill in the blank. A polynomial of degree n, as long as n is greater than or equal to 1, with real coefficients, will have n number of zeros, real and or complex, counting multiplicities. So as long as you address multiplicities, whatever that highest coefficient is going to be how many zeros that you have. Okay? So those are some fill in the blank. Now we are dealing with rational functions. You are not going to be asked to graph rational functions. What you're going to be asked to do is you're going to be asked to find the domain, and then we are going to find vertical asymptotes and horizontal asymptotes. Okay? So, in order to find the domain, what we are worried about is we are worried about the denominator. So, we are going to set this denominator equal to 0. We are setting the denominator equal to 0, and we are factoring. Okay? So, I have x minus 6 and x plus 3. Once I factor that, that's what I get. X minus 6 and x plus 3. Okay? So here, x minus 6 equals 0. And then I have x equals 6. X plus 3 equals 0. And I get x equals negative 3. Okay? Now my next one, so those are my vertical asymptotes. Okay, now my horizontal asymptote is, I look at the degree. So I'm looking at the degree of my numerator and the degree of my denominator. The degree of my numerator is 1. The degree of my denominator is 2. So, since the degree of my numerator is less than the degree of my denominator, my horizontal asymptote is y equals 0. Now, when it's the same, that's when you have the relationship between the two. Now, I want to go back and talk about this negative 3. This negative 3. We did not do one of these in class, so I want to talk about this x equals negative 3. If I were to If I were to factor this ahead of time, I would have 12x plus 36, x squared minus 3x minus 18. If I factored the numerator, I would end up with 12 and x plus 3 over x minus 6 and x plus 3. Do you see how at that point this would cancel out? Because that is something that cancels, the graph behaves differently at this point. So it is not a vertical asymptote. Now, this is not what I'm going to ask you on the test, but I do want to make sure that you just kind of realize what's happening here. So your only vertical asymptote is x equal 3. If you were to graph this, there would be a hole on the graph at x equals -3, there would be a circle because it's still undefined at x equals -3. It's just that you're not going to have a vertical asymptote there. I think the question's good. I like the question. If you got that your vertical asymptote is x equals -3, you're very much on the right track. It's just that the graph behaves a little bit differently because these two can cancel. Now, as part of your domain, though, you still have to worry about the 6 and the -3. Okay, x cannot be 6 and x cannot be -3 because of that. So even though we kind of are throwing that -3 out, when we talk about the domain, we have to account for that. Now, this is why it's important to draw a number line when you're doing your domain. A lot of students would look at this 6 and -3, and they would just say, oh, -infinity to 6, 6 to -3, and -3 to positive infinity. You've got to look at this in order of how it happens on the number line. 1, 2, 3, 4. Okay? And so the correct answer to your domain is -infinity to -3 union -3 to 6 and 6 to infinity. Okay? So that's our domain, that's our vertical asymptote, and our horizontal asymptote. So let's look at the next one. Our next one is 2x to the third plus 1. That numerator, this one is probably more like what you will see on the test. That numerator can't be factored anymore. My denominator, I have to factor that in order to find my domain and my vertical asymptotes. So I'm going to go ahead and factor the denominator. I've got a 3x that I can pull out of that. When I pull out the 3x, I'm left with x squared minus 16. Now, I'm only focusing on the denominator. I'm just looking at this denominator right here. So then I can factor 3x, x plus 4, and x minus 4. Okay, so 3x cannot be equal to 0. X plus 4 cannot be equal to 0. And x minus 4 cannot be equal to 0. Okay, so that is going to dictate my domain, and it dictates my vertical asymptotes. So my vertical asymptotes are x equals 0, x equals -4, and x equals +4. And those drive my graph. So my graph never ever crosses a vertical asymptote. Now, it could cross a horizontal asymptote. Now, the degree of my numerator is 3, and the degree of my denominator is 3. So when that happens, my horizontal asymptote is the relationship between my leading coefficients. So for this, my leading coefficient in my numerator is 2. My leading coefficient in my denominator is 3. So my horizontal asymptote is y equals 2/3. And remember, it's okay if we cross the horizontal asymptote. It might not happen, but it is okay if it does. And again, you are better off if you graph these points so that you put your interval notation in the correct order. Okay? 1, 2, 3. Okay, there we go. So we've got a whole bunch of stuff happening in this domain. So here's the domain. I start at -infinity and I go all the way to -4. Okay? Then I go from -4 to 0. Then I go from 0 to +4. And my last one is 4 to infinity. Okay? Okay, so that is it. I'm about to send this out in an email to you with announcing the test. I will be at a funeral tomorrow, and so we are postponing the test until Thursday. Okay, I'll still be answering emails. I'll have office hours on Wednesday. So you've got lots of different opportunities to come and talk to me. But I do want you to realize the test is going to be on Thursday now. And I'll put that in an email out to you as well. Okay, thanks so much. And I'll talk to you guys soon.